Right then, so do a little bit more on the valve amplifier. I suppose I should have got my pliers ready, the Douk audio one. So first thing I'm going to do is, I tell you actually no, first thing I'm going to do is turn that screen around so I can see what's recording. Right, so all the transformers took a hell of a hit during shipping. So I think what I'm going to do first is see if I can get the pliers on here and at least attempt to straighten these out, because I can't get the plier fully on because of the width, and everything's full of dead beetles. Where in its shipping it picked up a load of beetles, I do not know. I'm going to get under there. Look. Well, where are we? There's all dead beetles in it. Get out of there. Alright, one beetle down. So I'm going to have to bend it back. Let's get that in camera. Bend it back so I can then get the pliers on it, and that's not bad, is it? A little wonky, but camera angle's not great. I can't put the camera in front of me because then I'm trying to work around the tripod, so that's just not. It might get you a better view, but it would block my view, and ultimately it would completely block my access to the thing I'm trying to work on. So come on, let's go up a bit. The last thing I want to do is snap these off, and I do obviously have some ones that good. You can see they do stick out the bottom a bit. They don't sit flush with the lamination. It's about as good as that's going to get. This one shouldn't be too difficult. This only took a minor knock. Yeah, that'll do. Same as this one. So yeah. So let's start with the smallest resistors. Well, smallest components first. So some diodes, or as old matey, I can't remember his bloody name, off EV blog would call them, diodes, some diodes. These components are very oxidized, so I was having a few troubles soldering the diodes in, and some of that was partly down to not having the soldering iron up high enough, but the other part of the problem is some oxidation on the leads. So R44, R43, R44. going to leave them standing up a bit because they're something to do with the RC filtering, so there's a good chance they're going to get warm. So I'm going to leave them just off the board a bit, you know, sort of get tip of a biro under them. Just allow, if they're getting hot, it allows air to get around them a bit better. I snip the ends off because last ones I cleaned with meths because there's all Aussie glue on the ends. I'm just going to snip the ends off these ones. Gets the glue off them. Still loads of lead left on them. .47 ohm R3 and R23. R23 is there. R23's one of the cathode bias resistors, and so is R3 on the other one. So up here somewhere, R3, 47 ohms. So notice none of these resistors actually fit down onto the board fully. The edge of the resistor is actually further apart than the holes. Get it on camera, which I suppose isn't that bad a thing, because A, it means that the ones that are sticking up aren't going to cause me such a problem trying to put these ones in now, but it also means all the resistors get a bit more airflow around them, so that may well have been deliberate. You can never tell with Chinese manufacturing. Someone may have deliberately done that, someone may have just fudged the board layout up, but who cares? I kind of like it. I have a circuit board holding tool, but the problem with it is, when you're soldering, obviously it's nice to have like just a bit of something under it so you can push down on the components. If you use it, you've got to tape all the components up as you solder them, and that's a very time consuming and rather tedious process, because, you know, soldering isn't exactly the most enjoyable sport in the world. You need to be a patient person to do a lot of soldering in one go. .470k, this is the input resistors. It's a very high impedance amp at 470k. To be honest, there's just no need for that. I am going to drop that down considerably because it's just going to be asking for noise pickup. Actually no, I'm going to leave it because the input attenuator is 100k. So yeah, that's fine. That drops it down considerably. It'll change the response of the input attenuator, the potentiometer, if I drop them down to 22k. It'd have to be most of the way up before you even got half of the signal you was putting in. And it depends on what kind of if that's a true log pot, the last thing you want to be doing is loading it down with low value resistors. So 470k it wants, 470k it gets. So I'm actually having to bend them kind of like this to get them to go in, because they are so much bigger. Why they've got a 1 watt resistor for the input, especially at 470k, it would never get that kind of voltage across it to warrant being an entire watt. Again, I think they've just blanket pulled a stock of 101 watt resistors for everything out, whether the original board layout was intended for them or not. That's better. Soldering irons are working better now. I had it set on 25 watt mode, and I was just thinking, well, surely 25 watts should be plenty hot enough to solder with. And of course it's a switching, just a basic triac switching circuit inside, so there's going to be some losses in that. So you know, it maybe is drawing 25 watts from the mains, but maybe it was only getting 22 watts, 23 watts, and as it's a 50 watt iron, yeah, maybe it just wasn't quite getting hot enough. Well, it wasn't getting hot enough because it was soldering terribly. But now set on 30 watt, it's happily soldering everything. Ugh, I really wish I had my snips. Anyway, I don't. I've lost them. They are gone somewhere. It's an old pair of side cutters it is. So, next set of resistors. What we got here? 120k, that's going to be the R4, R5, R24 and R25. So same again, trim the ends off on them. Brown 120, yep. Really, especially for anode load resistors, one would generally use high precision and brown. What is brown is a percentage, that's like 10%, is it? What I'm going to do is I'm going to measure them, because you know, if they are genuinely 10%, that could be 12k difference. So one could be, worst case scenario, one could be at 132k and one could be at 108k. So give them a measure, see what they come out as. Got me some Porcupine Tree on in the background. Awesome band to do soldering to. 119. At least try and pair them up. 121. See, that's 3k difference. That's a big difference on anode load. 120. 118. These two can go on one amplifier, those two on the other one. At least they're somewhere near close to each other. So I should make these two R4 and R5 because that's one amplifier section. It's going to be up here somewhere on the input stage. 120k, 120k, there and there. R5 and R4. Turn down the iron a little bit because it seems to be running a bit hot. There's a lot of smoke coming off the flux and you can actually feel the handle of the iron starting to heat up. So of course the other issue is probably because its case is quite large and metal and it touches it, maybe when it was on the lower setting it was just sucking heat out until that whole case assembly, its iron rest had all warmed up. So that's one way to find out. Put it back down on 25 watts and see what happens. I think that's a bit better of a shot, a bit more in frame there. You know, if you do a lot of soldering like myself, and you obviously buy your soldering a 250 gram reel, obviously at some point you always end up dropping them when they're full. And I don't think there's a single reel of solder I've had where most of the entire time I've worked my way through it, I've ended up with a big chunk missing off of it because it's been dropped on the floor when it was full. Obviously when they're full they weigh a lot and they break. Need to get some more actually. I notice some of the part suppliers now, I don't even sell lead solder anymore. CPC still do, and you just can't beat it. I've got some lead-free solder up there and it's shit. Only thing I use it for is if I'm repairing something which has got lead-free solder in it, because if you try and use lead solder where lead-free was used before, you can end up creating yourself an awful lot of trouble. The two don't want to alloy together sometimes, or they sort of separate out, or any manner of things can happen. So 1K resistors. Alright, 1K. What sort of 1Ks for? Some grid stoppers. See, 4 grid stoppers, 2 feedback resistors. Yep, 6 1Ks. I'm gonna have to clean these off because there's fucking tape on them. Ah, cunt. It's not too bad actually. I like to check them all before I put them in, just to make sure they've not been mixed up or there's no duffs. And there goes my music. I've had this problem before with all of a sudden just cutting in and out. Google Chromecast and Deezer for some reason. It happens sometimes on Spotify as well. I know I don't have the world's best internet connection, it's only got 7 meg down, but at the end of the day 7 meg is more than plenty for downloading music. I can watch 1440p videos on 7 meg just about, so streaming audio should cause no problem whatsoever. It's more of a software issue. A lot of people have griped about it online. No one seems to find a solution to it. Oh, that one actually fits straight in. So I'm going to say that's the size of resistor they originally planned for these ones. Much, maybe a half watt. Obviously these are 1 watt, and then these were probably meant to be 1/4 watts and they've put half watts in them. So these are the first resistors that I've actually fitted on the board. They've got no pad. They're not going to fit in here properly, look. I really would like them to, especially being grid stoppers. Gonna leave them sticking up a little bit at the front. Might as well make them symmetrical. Nope, that's how they're going to stay then. And my Chromecast decided, well, these have stopped working through my Chromecast, so I've had to hook my phone straight up into the amplifier, which will do. I don't know if there's like any equalizer on my phone, so I'm fairly certain there is, but it's finding it, isn't it? Well, this has been on the 25 watt setting for a while. Okay, it's soldering, but it's flaking, I think. Yeah. Up it a little bit. So yeah, I've ended up putting the grid stopper resistors like this because they didn't want to sit properly. This is a through plated board, and at present the only joint really that solder's flown all the way through and onto the top side is this one here. But it doesn't matter, the others, you can see solder's actually started to penetrate up into the top layer, and they have a good amount of solder on the bottom layer, so they're good. I mean, I could go around and put some solder on the tops of them if I wanted, but I just don't think it's necessary. Ah, 270k, 4 of them. They are the anode load resistors for the input valves. Now, the input stage on this, it's very much like a paraphase splitter, but the true paraphase essentially runs more akin to a long-tailed pair. The maths to diagnose it, the analyse it, is interesting as well, because on the paraphase you end up having to put an additional resistor in series with the output of one of the valves, the second valve, the one with local feedback, I think, because the impedance on it is so much lower if you want to preserve an AC balance. But yeah, obviously they have feedback via the cathode and the grid on a true paraphase, and this doesn't. This has no cathode feedback from the load of the second valve to the first valve and vice versa. And the only feedback on this is there's an amount of anode to grid feedback local to V2 on it, the second valve, the driven one, not the one receiving the input signal. So It's kind of more akin to what you'd expect from an inverting op-amp stage, but obviously the valve doesn't have enough gain to work properly as such. So it's just an inverter stage really, it's just a grounded cathode, it's just a common cathode triode amplifier, just basically running as a simple inverter with a dollop of local feedback, negative feedback. So I'm interested to see how well it works. I might as well measure these or schematic again, try and at least pair them up. I think I will put the higher of the two resistors into the anode of the, into the feedback node of the two. That way it receives more signal. Going to be a more even output. 271. 270. 270. Maybe 271 would be nice. Excellent. So R27 and R7 I need to make 271 because they're the feedback ones. It's going to balance it out. R7 and R27. It's going to help get a bit more signal out of that inverter stage. Just going to make sure there's no mistakes. So it shows on the schematic as basically R27 being the same resistor as R7, but if you look, it is a mirror image board, and that could be true. So what I can check is the outputs. So that goes to pin 1. That goes to pin 4. Okay, and the feedback then should come from pin. Oh, what the hell? Well, that ain't right. Why am I showing both ends of that resistor being short circuit to... right. That explains it. Pin 1. Pin 2. Coming from pin 2 and feeding back into pin 1. So this one isn't, this one's feeding into pin 4. Pin 4, and it shows it on pin 1 on that amp, yeah. So then pin 5 should be the output on this one, which it is not. So yeah, pin 5 connects to R27, which it shows on there, so yes. Alright, yeah, we're good, yep. Worth checking that. So these are my higher resistors, so R7 and R27. Many of my Yamaha amplifier I have downstairs, the RN301. The schematic on that has a mistake on it. It shows on the output, well, the module that connects all the RCA leads to the back of it goes through an electronic switching circuit, and there's obviously lots of coupling capacitors. and it actually clearly shows on the schematic, like on the CD stage, obviously it was the only one I was working on, didn't bother checking the others, but it clearly shows two capacitors numbered wrongly to the actual parts on the board they connect to. So even manufacturers fudge their schematics from time to time, so it wouldn't be unreasonable to expect that maybe a eBay seller would do the same. I fudge schematics and circuit boards, we all do it, so it's always just worth checking. No harm in checking. So yeah, the reason what I've done there is look on the schematic. Oh. So obviously I had two resistors that were slightly higher value by K, and I've put them here and here because, like I said, I need as much signal from here as I can to drive this second valve. So by these being ever so slightly higher, it's going to be slightly less feedback, so it's going to give this valve a bit more gain, and it's going to give less attenuation at this point. It's just going to help balance the signals out a bit. That is all. So the other two 470s I want are going to be R6 and R24. No, R26 even. So R26. Tip had come loose there, ever so slightly. Obviously it's gone hot and expanded and come loose a bit. Sort of thing you can't just get the pliers and wrench it on because you don't want to end up twisting the element off the thing. So I think I've got some movage underneath there. Yes, I have. Hot, hot. Some more 1K resistors. So, more 1K resistors. Why have I got more 1K resistors? Didn't I already have 6 of them? These ones are bigger, much bigger. I don't... No, R13 and R33. So yeah, they will be the 1K resistors for the they're these resistors here. Do I run it tetrode mode or do I run it ultra linear? The amp over there is running tetrode mode, the one that you can occasionally hear in the background, and that's single ended and it's actually pretty good. Let's examine the board here. So pins 4, all the pin 4s, how easy is it to... So it's there, there, so I'd have to chop there, resistor, wire. Do you know what? Fuck it. I am going to build it as they intended. I'm just going to put then a much bigger capacitor on here because 22 microfarads is quite low. Although it does have a 1K resistor, that is quite low impedance anyway. Fuck it. If they send it out like this, I'll build it like this. I am definitely not with cheap Chinese valves, leaving them sharing a cathode bias resistor, though. That is not happening. So yeah, completely gone back on what I said I was going to do. So R12, R13 and R30, that's interesting. Ah, these are the input grid stopper resistor. What the hell? R2 and R23. Where's R32 then? What am I missing here? R12 and R32. Oh, those are the feedback resistance. So it turns out I've already put them... Where have I put them then? Which ones are... Oh, R13 and R33 I've put in here and here. So, and that should have really been those ones, definitely. Right, that's why they fitted in there then. Because I've put these would have obviously been the ones designed for the feedback circuit. And these obviously, because they're going to be more high voltage current across them, these were the ones designed for... Should have paid attention to the fact it says 2 watts on there and 1 watts on all the others. So, it's time to get the solder sucker out. Right, she is up to temperature. Boy, is that up to temperature. It's got it set at 400 degrees because it has a tendency to block the nozzle up otherwise. So the 2 resistors I want to take out are R33 and R13, I believe. Yep, because they're Christ, can't think. They are the grid 2 resistors for the output stage. So a little bit of solder on, get it hot, and job done. Fantastic piece of kit to have. That was almost impossible to desolder double-sided board with braid and a soldering iron because it just doesn't wick through. Get it nice and hot, and it's blocked up. Right, I'll be back with you. Try that again, shall we? So I think I might have had it up a bit high, because if you have it too high, it can oxidize the solder or something. And I also tried to desolder the wrong resistor anyway. So, and there may be a blob of solder in here from previous desoldering. So let's try again, shall we? Drop of solder. Get some heat through, and that's more like it. So it blocks it, where it blocks up is just here, which is really annoying. If you get you take this off, get the soldering iron, and you can just melt it and push it through. It's like it just needs to get hotter in this bit. So I'm not sure, maybe if I just knock the solder down. So it's definitely sucking it the minute. It sure does suck. So I might need a bigger tip as well. Maybe it's because the resistor leads are just too big and it's blocking the airflow or something. I don't know. Give it a poke through, too big. See, look, perfectly clear at present. That's going all the way into the into this bit. I always forget they get incredibly hot for a very short period of time in there. That one seems to have plastic all on it. There's some plastic melted to it. Nice. Last thing I want in there. Yeah, that's clear. So anyway, that's them desoldered. That one and that one. Just wants a little bit of heat. Just to... There we go. Right. What was it? These two, wasn't it? Don't you hate 5-band resistors? Like, seriously. Is it brown, brown, black, black, brown, or brown, black, black, brown, brown? Check the value. $996, $997. I'm having to run this camera on a minute off the battery because I found in my last video if you run it off the charger, because it's a switching charger and it won't charge the battery whilst the camera's turned on, it will only run the camera, and it sounds like there's a life support machine in the background because every sort of 10 seconds or so the charger kicks in. Obviously switching supply obviously lets it drop down, boosts it up, pre-regulator, and you can hear the noise gets through to the camera. So I've got another lead coming. I'm going to make my own 5-volt linear supply, so if I'm doing a long video, rather than having to run it off the battery, I can just run it off the power supply. So the big resistors want to go in R13, and R33. That's better. It's good to make mistakes. Mistakes are how you learn. For instance, I was just looking at the schematic again and I realised there are a couple of 220k resistors rated at different power ratings, and some are for that input phase splitter and some are for the power supply. So it's good to make mistakes, because generally I've spotted that one, now I'm going to be more aware on that from going forwards. And I've built enough things, you would have thought I'd have looked into that, but obviously with the instructions not being instructions, being nothing more than a schematic and a parts list, you kind of forget about some of the simpler things that would normally point out in an instruction book. And obviously when you design it yourself, you're well aware of what size resistors you want to use. But someone else's design, you know, you can just get so bent up in 1k, 1k, 2k and the 2k resistor numbers, you forget to look at simple things like what power rating are they meant to be. So these are going to need a bit of a bend in because they're going to have to fit in a smaller hole. Hopefully there's still enough leg left on them. It's going to be a squeeze to get the pliers on them. Plenty of room, plenty of room. Just sticking out through the other side of the board. Perfect. Got this soldering iron sat at about, it's not quite on 30, maybe 28 watts, and it seems to be at just the perfect temperature. So yeah, I'm going to say it. The internal control board, yeah, it's got some heat in it. It's obviously consuming a few watts as well. So the power draw of the iron isn't solely the amount of power drawn by the mains. There's going to be slightly more. So obviously my power measurements on it were a little bit off. Yeah. Right, so we're down to our last few resistors. I'm going to say red 220 plus an orange 220k. Yeah, there's a 220k 2 watt for the LED. Just give it a measure. Wow, yeah, 220k. Of course, if I put my fingers on it, it reckons it's 140k. Joy of being in the 2 meg range. R41, yep. So the LED actually is on board. That's weird. There's no connector to say the LED is going off case anywhere. It shows it as being just an onboard LED, which you'll never see when the amp's together. But I suppose, admittedly, if you can't figure out if a valve amp's turned on or not by looking at it, you've probably got problems, realistically. $220k and 220k, no? What are these ones? Brown, black, red, 100, 100 times black, brown, red. 100 times 100. My maths has just gone 10k. Are these 10k? I can see some 10k's actually on the board that need putting on. Yep, 10k. 10k. So these are R2, right, input grid stoppers. Yeah, R2 and R22. Ah crap, just caught my soldering iron. So yeah, I'm down to the last resistors on the board apart from some of the bias ones and stuff. And as I've said, I feel these 220k here, although they're going to allow these ones here and here, although they're going to attenuate the signal across this chain less, it's just too much for my liking for grid leak. If you get, what can happen is a positively charged gas ion can come down and end up striking the grid, and that then draws the grid potential slightly positive, and that needs to leak off. Well, an electron needs to come in and what's the word I'm looking for? Jeez. It needs to remove the charge. It won't dislodge it, that's not the word I'm looking for. Basically, it will cancel it out. This will become positive and the charge can return to zero. If this is too high, what can happen is the valve can start conducting heavily. As it warms up, you start getting outgassing from the internal structure of the valve. More and more positively charged ions start striking the grid, because they're the first thing it comes to between the anode or grid 2 and the cathode. The grid potential starts to rise, the valve turns on harder, it gets hotter, more, and you get thermal runaway. So there's a limit on the value of grid leak you want, and I kind of wouldn't go above 220k myself at the best of times on a self-bias amp. I'd keep it down at maybe 47k or so on a fixed bias amp, especially with more modern valves or older valves that can get gassy or aren't made that well. So I'm going to put these down to 47k when the amplifier is running. Test how well it works, because obviously that's why Dynaco did it all those years ago. They were well aware that they would have got better performance from the circuit with some higher value resistors, but it's just too much grid leakage for my liking. So I've got these little 47k half watts, I think, maybe 1 watt, I think they're 1 watt metal films, I believe. So they're going in there. So that will be R30 and R10. If you haven't figured it out by now, every resistor on the left amp, the right amp is 20 or 10 higher. So R10 is R20 on this amp, R3 is R23, well, 20 higher. Yeah, R10 is R30, R8 is R28, R27 is R27, and so on. So yeah, R10 becomes R30 on this amp because they're all 20 higher. So where it says 220k there, it's getting 47k's and it's liking it. So of course the other thing to do is then I'm going to have to take a knife to the board to sort out these cathodes on the output stage, because there is no way I am running this, as I've said several times, with the output stage cathodes tied together. It's just not happening. Gonna need like some 470 ohm resistors and some capacitors to go across them, so I will do that and then I will film it when it is done. So what I need to cut, so here's the standard cathode resistor, so you can see it goes round to the first valve. That's the same here, so I need to cut this track here and this one here. Now obviously when this is in the amplifier, the valve sockets are going to mount that way on, all the components are downwards, so I'm going to have no trouble that way. So I'm going to have no trouble at all soldering a wire across to here and just putting some resistors and capacitors here and here somewhere. So, bit of Dremel time. Should have done this before I put the resistors in, really. Guess I'm going to have to do it right here. That's one. Yep, I've got dust in my eye. That one's cut, and do the same here. Job done, and that's them cut. So you see it's now coming round to this valve, but I've broke the link to this one. It's coming around to this valve and I've broke the link to this one. So wire to there, some components here and here. So, got that done. As you can see, a little bit messy, but what the hell. So that's capacitors now for this one, this resistor chain, and this cap for this one. Resistors for the outer two and their caps. I had to give the caps, you probably won't be able to see it, a bit of space off the board because there's the cathode trace actually runs under where this negative lead is, so it's spaced off, and the lead on this cap is bent down, holding them up off the board as well. It's just a bit of double contingency there. I've come straight through and straight to the cathode connections on the valve sockets. So I have only one more resistor to put in, and that I'm going to call it a day for this part. I shall do more another day. So I have this, it reckons it's a 10 watt 100 ohm. And that is labelled as, where is that on here? R42. It's going to be bigger than the power supply. So yeah, look, they made it for a 5 watt and this is a big ass 10 watt. That's going to be fun getting that in there, isn't it? Let's see, look. So it's this one here. That's the resistor, and that's the hole it has to go in. So yeah, there. Going to be a bit of precision inward bending. I don't know what just happened there. Something like that. Again, it's going to sit off the board, so it'll run nice and cool at least. See if we can pull that through a little bit more. Should clear that cap, hopefully. We'll keep it outwards. So what we'll do, we'll spin it round so it sticks out this side towards that cap. Job done. Well, you can tell I've not got this soldering iron turned up very high. Did the first joint alright, but it stalled a bit on that second joint. And that is enough for one video, and if I have no idea how long it's going to be, obviously I'm going to speed bits of it up, but I've got an awful lot of footage for the last couple of hours up to this point, so if you have sat and watched it all the way through to here, then all I can say is massive respect for you, and thanks for watching, and as always I'll be back again at some point with something else, but for now, cheerio. Thank you very much.